Okay, today we're going to learn how to use the Copasi to testify our mechanisms and trying to find out the reaction rate of each step of the mechanism. Firstly, there are two things you will need. It is the proposed mechanism and also your data you gained from your experiment. Firstly, you will need to open your data in the Excel form, as you can see I made it for the estimation. Then what you will need to do is trying to save your data in a text tab delimited form, and I will save it. Yes. Then you will need to open your Copasi. Get it from the official website online. Don't need to Google that. Then the first link, you can find the model free online. Then, as you can see, there are a few sections here on the left side. Firstly, you need to build a model yourself. Just in the biochemical subsection, you need to input all the species on your mechanisms. And usually I just name all the species in my mechanism just using their molecular weight, so it's easy for me to remember because I use it in mass spec. Firstly, you need to double click each species, or just need to click on that so you can name it. For example, our first species is 844, and also about the initial concentrations. I would like to just using the relative intensity as my initial concentration. For this one, I remember it is 0.97, and just trying to input all the species even it's not charged in your mass spec. Our second one is 103, and because it is one of the intermediates, we don't know, so just trying to regard them as 0. Then just need to input all the species. I don't have to fill all the other stuff. After you input all the species under the species subsection, then you will need to fill out the reactions that all involved in your mechanisms. Firstly, I just trying to name all the reactions in the order of my mechanism. For example, I just trying to name my first reaction as number 1. and trying to input the reaction. I will just input reaction. You will need to input your species in the double quote. For example, the first reaction is 844 dissociated to 741, so 844 double quote. And because it is reversible, we should use the equal sign. And get the other two species. One is 103. The other space is 741. Then it's done. As long as you get the background in blue, that means you input your reaction in the correct way, and it's reversible. We can click that, and don't click that. Then it's reversible. Now you will need to estimate your reaction rate or kinetic reaction rate on both the forward and the backward reaction. Usually, because it is slow step, I just estimate that as 0.01. If it's anyway, I'm gonna estimate that later. You just need to take a good guess. Then it is done. Then we're trying to add a new reaction. The same way. Now this irreversible. It is 741. React with the tributylphosphane is 4202. And now it is a irreversible way, so we should use this dash and right bracket. Then it formed 943. Now, as you can see, the background turned blue. That means you get it right. Then for the reaction rate law, we can choose irreversible mass action. Because this is a fast step, I just estimate that as maybe just 50. Then you're done. I'm just trying to input all the reactions. Now, as you can see, we have done most of the work trying to input all these species and reactions from our mechanism into the Copasi. Now, what I need to do, trying to go to the task subsection, find the parameter estimation. Now, firstly, you need to upload your data, experiment data, received before in our computer. I'm trying to find it. I remember it is on my desktop for as the demonstration. Click on that and open it. You have to remember your data in a text delimited form so it can be read by the computer. Then, most importantly, for the experiment type, you should choose time course. Then you can recognize your time. Then for the other species, you're trying to find the type. For example, the first one is 883. This is my first species, so I should type the type of this species should be dependent. Then trying to find, because this is concentration, trying to find the species, transient concentration, and trying to find the corresponding name. Yeah. Then trying to do the same thing for all the other species for your data. Transient concentration is 784. Now you're done, just click on OK, then finish this. Then you will need to tell your Copasi what to do next, what you want to estimate. Then trying to go to the object, click on this. Now you're trying to find the reaction rate. So you go to reactions, the reaction parameter, and trying to open all the reactions. And trying to choose all the reaction rates. Click on OK. As you can see here, you already input all the reaction rates you input before from your reactions. Now you need to tell this Copasi the range you want trying to search. I just choose the lower bound. Usually, you just need to set minus 100% because it won't go negative, which is insane in most cases. For the upper band, I usually, because I'm not a good guesser, I just set a 500%. Then just do the same thing for all the reactions. And you can see the very standard value for each one. Okay, now you have input all the ranges for your parameter estimation. Now you need to set out for the output. It is quite tricky because we will not output directly. You need to click on the output assistant, trying to choose the parameter estimation result, then create. Also, we're trying to create a report so you can check it out later, and just trying to name it, maybe just for is 100 equivalent in 3. And I'll try to save it onto the file I just made it here. And save. And click on OK. And also for the method, usually I'm just trying to use the genetic algorithm. And it's almost done. Then you can run it. Just wait for a few seconds. It is done. You can check your data, and you can save the images or save the data under the designed file. Also, later, if you want to check your data, you can just click on the parameter estimation. There's a result here. Then you can check the parameters. Then the value is already set for you. Then that's done. Now, as you can see, when we check our parameter estimation results, it is the value the Copasi works for you. And as you can see, this lies within the upper bound and lower bound. However, in some cases, you will find the value equals to the upper bound. That means you set your range for this parameter too narrow. So you will just choosing the highest value. If that happens, you will just need to come back to the parameter estimation, trying to set another value for that parameter. Maybe just trying to set it higher, maybe from 500 to 1000 or 10,000, do whatever you want. Then trying to run it again. Then you are done. Okay, now we got our parameter. We need to testify whether these values works for us. Firstly, I will try to copy and paste all the reaction rate into the reactions here. Just copy and paste. Do it one by one. Now we have input all the estimated parameter into our reactions. We need to run the time course to testify this. Firstly, you will need to see your output specifications. You will need to make a plot. So I should make a new plot, try to name it for time course. And I'm trying to add it on the plot here. I'll try to make a new curve, and I'll try to set my x-axis as the time for the model time, and the y-axis as the species, and as the transient concentrations. I'm trying to find the space that you want. Is last 4. Click on OK. Then it is done. You come back to the time course, trying to set the duration of the reaction as 600 duration in seconds. Interval size just as 1. It was a true forward experiment. Then trying to run on this. As you can see, it is the estimated reaction rate for all the 4 species. Now, how can you try to testify your mechanism? You just need to try to change the concentration for the other species, trying to find whether it will change correspondingly as your experiment data. Now, just trying to obtain equivalent, come back to the time course, and run it again. On this side. And trying to run it again. Then trying to see whether the line corresponding to your experimental data, if it suits, that means your mechanism is right.